In this episode of Disassembly in the Dark, where I typically blindly reverse engineer a program, I'm bringing the equivalent of a virtual torch, or torch if you're from the UK. This time around, I'll be using an AI/LLM tool called GhidraMCP that goes along with, you may have guessed, Ghidra, the reverse engineering tool, in order to help us along the way and just check out how MCP can help us be better, more augmented reverse engineers. GhidraMCP was developed by Lori Kirk. You may know her as Lori Wired on YouTube, and if you don't know her by either of those names, you definitely need to go check out her channel on YouTube at a minimum, and go follow her on all her socials because she puts out a lot of great reverse engineering content, tools, and just general computing cool information and stories. And I'm even more excited to be using this tool on one of my personal favorite childhood games, definitely in the top 10, and I'd say one of the most requested programs to reverse engineer on the channel, the original Sims. I talked about in our question box video, and I know I've talked about it before, how important it is when you're reverse engineering to set very small, definable goals so you don't get overwhelmed. And I've tried to do that leading up to this video with 4 different goals for The Sims. By the way, my daughter painted my nails. I hope you like them as much as I do. First goal, infinite money glitch, something I always wanted to do as a kid. Second goal, make it so the moodlets never go all the way down. Those are the things like hunger, bladder, fun, etc., etc. Another thing I wanted very, very badly as a kid to never have to worry about that and just focus on playing and doing whatever else in the sandbox. Goal number 3, find a way to modify the game's animations in some way. It can be any way, really. I'm setting the bar very, very low because I don't know how complex this is going to get. But that's something I've wanted to do since I was an adult reverse engineer, I guess. And number 4, most important, save the Sims from the infamous ladder removal trick. If you don't know what I'm talking about, it's when you put Sims into the pool, they're swimming around having a great time, you enable the move objects cheat, you click on the ladder, and you take it away and they're stuck in there forever. And I talked about this kind of cruelty in the beginning of my second Roller Coaster Tycoon video, and I also actually had the idea for this kind of breaking of the ladder removal trick back in the autumn of last year, and I know I've talked about it or hinted at it in a few videos now. So why did it take this long to get this video done? Well, I ran into issues last fall when I tried to record this initially. It was a completely different concept actually, but the ladder thing was part of it. And I have the original CD-ROM of Sims 1, had driver issues, couldn't get it to work, and long story short, just kind of gave up after a while and did the Splinter Cell video instead. So that's kind of how we got here. And also I've just been working on balancing mentally all of my hobbies, and this being one of them. It's been difficult to find the time and be in the mood to make this happen, but thanks so much for the supportive comments throughout that time and for your patience. And honestly, I'm glad things worked out the way they did, because now we have Sims Legacy Edition and we have the GhidraMCP tool, and I'm just so excited to finally make this video into something that I never planned it to be, but I'm excited for. And more importantly, I think it's going to be really, really fun. At least I hope it is. So without further ado, we've talked enough. Let's get started. I'm Jeff of All Trades. Let's see if we can't master this one. Ooh, welcome, everybody. It has been so long since I have sat in this setup, and I'm so afraid I'm going to mess something up because I have not recorded in a long time. Appreciate you all waiting for this one. I'm really, really excited. Not just because I get to play The Sims 1 again, but because I get to do it with you all, and we're going to try to do some cool stuff and potentially break it or potentially unlock some cool self-made cheat codes. Before we get started, GhidraMCP, I talked about this in the intro, tool by Lori Kirk or Lori Wired. Awesome tool. I've actually been playing around with it outside of the context of this video for a few months now. So I'm going to do a very quick setup. I probably won't do like a full tutorial on how to set it up because the instructions are really clear, but I actually have to update my version anyway. So I figured I'd record it. And if you all have trouble setting it up, you can at least watch me do it once, and it might be helpful. If you don't want to watch this, just skip ahead to the next chapter. That's why we do chapters. All right. I don't know if I've watched this little preview video, but we can check it out real quick just to give you, oh, that is so loud, sorry. Just to give you a little preview. And this will do even better. This is doing my job for me. So already the AI is doing the AI thing that it does best. Yeah, this is going really fast, but to put it simply, for those who may not have used an MCP tool before, Model Context Protocol is what MCP means, by the way. It's kind of a way, to put simply, it's kind of a way to tell a large language model or LLM how to use tools that you make available to it. So I'll show you, that was obviously a very quick demo of some of the things that GhidraMCP can do, but let me show you how it kind of interfaces with Ghidra as a whole by going to this bridge MCP Ghidra file, which has methods defined in Python for all of the different kind of hooks into Ghidra that the LLM will have access to. By the way, I'm making up this verbiage. These aren't real words. What are words anyway? Let's see. So we have list exports, list imports, list segment, rename data, decompile function, which is extremely handy, obviously, especially if you're just beginning reverse engineering. It's kind of like having a little bit of hand holding for you. Obviously, Ghidra has a decompilation view as well, which we'll see. But this will actually not only decompile it, but you can ask it questions about what it decompiled and what the purpose of that code might be. So very, very powerful already. And they've even updated this since the last time I used it. So there's a lot of different functionality in here that I haven't even used yet. Get function by address, list functions, decompile function by address, all sorts of tools that instead of, writing codes or Ghidra scripts or extensions to do this kind of thing, you can just ask ChatGPT or Claude or whatever LLM you want to hook up to this thing that supports MCP. You can just ask it to do those things for you, and it will know, because of how it's been told through this MCP kind of spec, it will know what methods are available to it and how to do those things via Ghidra, the program running. And yeah, it's going to lead to a really cool, very human readable, human speakable, human typable, I guess, conversation where you can just have it help you as you go through your disassembly, which I think is awesome. This is exactly the kind of thing, I love to see LLMs used for. So thank you, Lori, if you're watching. I doubt you are, but if you are, thank you for this tool. Really enjoyed it so far, how I've been experimenting with it. Let's go ahead and install it. So again, pretty straightforward install instructions. Let's go ahead and download the latest release. I'll go to the release page, just click on the zip. And then as we see back here, I'm going to go ahead and open up Ghidra. There are some prerequisites, so make sure you have Python 3 and the MCP SDK installed. There are instructions on how to install that as well. I already have them, and like I said, I'm not going to do a full tutorial here, but I remember it's pretty straightforward to get those things installed. Oh yeah, whoops, I forgot. I already ran Ghidra, and in fact, we still have the Splinter Cell project in there. So let's go ahead and start our new project, non-shared project. It's going to be 2025, baby. And we'll call it Sims. All right, we're not going to do anything with that just yet, but let's go ahead and get the extension set up. So first thing is I have to get it to somewhere where Ghidra can find it. I think I actually put mine, I'll share this on my screen in a second. I think I literally just put it in a folder called testing somewhere random. Yeah, in my documents here. So let's go ahead and get rid of release 1.1, unzip, maybe, unzip release 1.4. Go ahead and delete that zip. And I think that should be it. Yeah. So let's go ahead and go back to Ghidra. Also, I don't know if I'll remember to use it, but I do have a nice handy shortcut now on Windows. It's not quite as smooth as the Mac one, but to zoom in when I need to for emphasis and other things. So file, and what do I want here? Install extensions. So this is the one that was already there. I think I need to, let's see, maybe I just click add again. I don't know if it's actually using the same old version or what's going on there. So let's see. All right, cool. So if you do click on it, you can remove the existing one, which is great. So you'll notice, hopefully you noticed, or you can rewind and see it. I clicked on within this GhidraMCP release 1.4, there's a zip file, and you want to leave that one as a zip file. It's separate from the zip we downloaded. Leave that as a zip file, click on that, and that's what you want to install. So that should be good now. We'll need to restart Ghidra. We'll do that. I don't have the latest. I didn't update my Ghidra, by the way, so I'm using the February 19th build, just FYI. Hopefully not too much has changed. And now we need to actually see if this extension is working. So a couple things I'm going to touch on here. Number one, I'm going to load up the Sims executable from the Sims Legacy Edition. And let's go ahead and get that running so we have some file that we can kind of check out. Couple things, and she notes it here, make sure it's enabled in file configure developer. So it should be enabled already, but let's go ahead and make sure. File configure developer. I think actually, now that I say that, I think I actually want to be in this view. Let's make sure, but I didn't see it there, but I think if you open it in here maybe, and I'll go ahead and kick off, I'll go ahead and kick off the analysis, which opened up my other screen here. And let's see if it's in here. Oh, well, I may have broken it already. Let's see. There it goes. It just took a minute to load. Let's see if any of these will open up. There's a lot of stuff going on in Ghidra right now. This poor Java heart can't keep up. Oh, okay. I might need to update Ghidra anyway, because this might be... Yeah, this might be a version mismatch that's going on. Sorry, one second. Oh my gosh. So there, I downloaded 11.4, and there's apparently a bug where you can't add an extension here. So I'm going to try this with 11.3.2 and see if it works better. Hold, please. All right, we are cooking, and this probably is for the best because the GhidraMCP, the newest release, is made for 11.3.2 anyway. So we'll go with that, and we will go right back to restarting and hope that everything has gone well this time. All right, so a few things before we get started. Configure developer. I think, like I said, it may not be that view, but once we actually have the disassembly window open, let's see, that we actually get to turn, make sure the extension's turned on. But yes, I would like to configure them. So by default, I think we'll see it actually in our options later. There's a port that will, this service will be running on 8080. So I want to say when I first tried this, I had issues with something else running on that port, but we will see if that's the case. Let's go ahead and see if we configure. We see it. Okay, it's turned on there. Everything is pointing to everything. Everything is pointing to GhidraMCP. Sorry, Ghidra running on 8080, and I just closed it. All right, this is what happens when you start recording at 11:30 at night and know it's only going to go downhill from here. All right, so that's all. I'm not going to touch anything else. That's all working and fine. We've gotten through the GhidraMCP installation. The next thing we need is a way to interface with our chosen LLM, and for me, I'm using this tool called FARx. I don't really have a preference. This was just one of the ones that was on Laurie's page for GhidraMCP. I tried it out. It was easy. I liked it, so I stuck with it. Feel free to use whatever tool that you're most comfortable with. They also have examples using Claude Desktop, Klein, and then, yeah, there's the example with FARx. So FARx is the one I went with, and I'll show you how that one works, but know that you can set this up with any MCP supporting tool you want. Actually, before we get into FARx, the other thing you'll need is a API key to whatever LLM you're going to use. I'm going to be using ChatGPT, so I have an OpenAI API key set up here. You can go get one by going to platform.openai.com, setting up a profile, going to API keys, setting up an API key, and you will probably need to purchase some amount of credits. Now, before you run away from that, let me tell you that I paid $5 for credits when I first started playing with GhidraMCP like months ago, And I have barely made a dent for all of the different queries that I've been making with it. I've barely spent 93 cents or so of it. So it's not going to break the bank to get this just for personal usage or experimenting with it. So with that being said, once you have your API key, we can go back to Fire, and you're going to go under your Tools menu here. Obviously, these instructions are going to change for whatever program you're using. For Fire, you're going to go here. I've already created my tool, but you'll go up here to plus local, and then I'm going to click edit instead of creating a new one and just show you how I set this up. You give it a key, you give it a name, and most importantly, you give it a command. So this command here is pointing to the bridge GhidraMCP Python file that is, now that I look at this, I might need to change my path now that I've updated. Let me see what it's going to be now. Yeah, so over here it's in this path now, so let me fix that. And we should be good there. I don't need anything else, I don't think, because that should start up the server. Let's go ahead and click save. And let's go ahead and flip this on. And if we get green, that's usually a good sign. But the ultimate test is, can you connect? Did it fill that out for me automatically? Did I type that? I don't know. Either way, that is the question. So let's ask it, do you see the listing open in Ghidra right now? Okay, maybe we have to be a little more specific. Tell me about the entry function open in Ghidra now. There we go. So right there, it flashed up for just a second there. You could see the MCP method it was calling. And let's see, is named entry. It's located at this address. The function does not return a value and does not take any arguments. So very basic stuff, but that's okay because for now, we don't need the details. We're not decompiling anything yet, but we at least know that the MCP is working. By the way, you can see how many tokens you're using per prompt here. Keep in mind that that is how you are charged. So take a look at what your token quota is, and keep in mind that the longer the response and input into your LLM is, the more you'll be charged for that prompt. Something to keep in mind. Cool. So yeah, I'm feeling good about that. We got our setup here. Let's see. Let's go ahead and dive into actually starting up the Sims, or taking at least a quick overview before we dive into the disassembly. I just want to check some metadata of the file. I'm trying to think back to all the things I usually do when starting up like a reverse engineering thing, because like I said, it's been so long. I want to take a look through maybe Resource Hacker first and some other things before we dive into the disassembly, and just start the game up and make sure it works, because I just reinstalled it. So we should probably make sure it works first. All right, so in Resource Hacker, trusty program that you probably saw in my malware sandbox video, I like to open this, or actually maybe not the malware sandbox video, maybe actually the solitaire video for the first time. Either way, I like to use Resource Hacker just for a quick look at the very basic metadata in here. You can see some icons, icon groups, version info, which this is so funny. Will Wright's People Simulator. That is awesome. I don't know if you all find that as awesome as I do. The only reason I'm saying that's awesome is because Will Wright, if you don't know, is creator of The Sims. And it just brought back a warm memory of a couple of years ago, I was on a military mobilization, and I had bought I hadn't bought it. I had tried the free trial of the masterclass website and tried out some of their classes. And the first one I did, and the one I ended up loving the most, was by far and away Will Wright's. His course was about game design, of course, and just listening to him talk about how he was inspired by systems thinking and how he went about creating the first sim games like Sims and SimCity. It was really cool to hear him talk about that. It was truly what I would consider a masterclass, and I still have the PDF saved somewhere. But yeah, if you want to do the free trial of masterclass.com, not a sponsor or anything, his was definitely worth the watch for me. It was just cool to listen to him talk. But anyway, I just thought it was funny that it's called Will Wright's People Simulator in the comments there. But not much else really going on in here, honestly. We got a short manifest, version info, no images, nothing much there, which I didn't expect to find anything crazy, but just always like to open it up and see just on the surface what's going on here. All right, let's go ahead and start the game up next. I'm going to pull over the wretched EA Games app launcher. I think I speak for all of us when I say that I dislike this software and the fact that every game studio has to have their own launcher now. I think this is the one I want. And by the way, in case you're wondering why I'm a beautiful woman, this is my wife. It's my wife's account, but we share it. And I'm hoping that everything will just go smoothly this time. I don't think I had any trouble the first time I launched the Legacy Edition. It was really just the disk one that I had trouble with Windows 11. Uh-oh, there we go. Oh, you turn my volume down though. Oh, right away, the hit to the nostalgia. Just that music. Jerry Martin, I think, is a composer. Wonderful, wonderful contributions, Jerry. If you're watching this, you're not. But if you were watching this, I'd tell you what wonderful contributions you made in my childhood. Oh, sorry, I'm just taking this in for a minute. I have so many memories playing on my little Windows, what was it, HP Media Center PC, booting this up and playing this. Is this text Comic Sans? Okay, so tutorial and everything. All right. I remember doing this briefly when I first started up. Oh my gosh, I've forgotten every single control here. There we go. All right, I don't really need the tutorial. I really just wanted to see everything work. Can I just stop the tutorial, please? Yeah. Okay, there we go. Just hitting escape does it. One thing I'm looking at is this is running in full screen. I want to say there's a way to get it to run in windowed mode. 1 second. All right. Oh gosh, I forgot to save. I don't want the help center. All right, cool. Pause. So apparently you can hit Alt-Enter. Yes, perfect. And put it in windowed mode. That is great. And if I could just have, yeah, windowed full screen would be fantastic. All right, I feel good that everything is working so far. Knock on wood. So let's remind ourselves 4 objectives. Infinite money glitch. Moodlets aren't impacted by anything. Do something with animations. I don't know what yet, but I have an idea from when I was doing my experimenting for the first video concept. I have an idea of what to do there. And then the ladder, of course, the ladder is our primary goal, but we're going to save it because I do want to explore these other ones first, because I think they will be somewhat, when I say simple, I mean in a relative sense. I think they'll be somewhat simple reverse engineering tasks because I have an inkling of where to look, for example, for the infinite money glitch stuff. So let me go ahead, let me bump up my font size here, maybe, and make it a little bit nicer to look at. 1 second. All right, I don't love this theme, this dark theme, but also it's saving my eyes a little bit. So I'm gonna go with this, and then let me, like I said, let me just bump up the font size a little bit more. What is it under? I thought it was under display, listing display. I had it backwards. Let's do like 14 maybe? Better, I guess. And I will try to be liberal with my use of the zoom when we need it. All right, so we are just loaded into the Sims exe entry point. When I was thinking about the infinite money thing, my head first went to the cheat code that is burned into my brain for all time for money, which is not motherlode in Sims 1. That's the Sims 4 one, sorry. Oh, that's embarrassing. Rosebud. There it is. And my thought is we can probably... I deleted my preference for the cross references. Let's turn that up to... Where's it at? Oh, I see. So the the cross references are showing. Okay, so maybe that's part of a string table or something. That's why it doesn't have a particular cross reference to it. Okay, so we might have to work a little bit harder than I thought to figure out where this is being used. That's okay. I'm up for a challenge. Porn tips Gazzardo. Flip. Interesting. So there's a lot of interesting strings here. I don't want to get too deep into this rabbit hole yet, but there's a lot of interesting strings here. Okay. So how are we going to figure out where Rosebud is used? So let me back up. Why are we doing this? Why are we finding Rosebud? Well, Rosebud is the cheat code that gets you, I think, 1,000 more simoleons. So if we can find how that cheat code is working, ostensibly, we should be able to reverse engineer how to modify the amount of money your Sims have within the game's code, within like a debugger. And then we can kind of figure out how we would write a cheat code to keep that at a very high number or just never detract from it or something like that. We'll figure that out when we come to it, but the first goal is to find out where Rosebud is being used and see if it can help us get to where the money variable is stored in the game's memory. I'm going to go ahead and pull over my debugger x32 debug over here, connect to the Sims. This is actually a pretty good font size. I must have saved this from last time. And then let's go ahead and find where this is in memory. It should be in the same spot. And then we can put a breakpoint on it and figure out where the game accesses it when we type in that cheat code and use it. So let's do that. I think that's where my first step is going to be. What do I want to do here? I always forget to change my key bindings for Ghidra and the debugger. I have forgotten. We are probably seeing some ASLR, address space layout randomization. Yeah, I think there's a way we can fix this, but I'm going to have to see how we can do this. 1 second. Okay, yeah, so I'm using a way that I have written down a long time ago. It's probably not the best way and far from the only way to disable ASLR, but there is a Visual Studio tool called Edit Bin where you can do this. And I have the command for it, but I will add this to the list of links to give you in case you're on Windows and you want to install this thing. You just want to download the build tools for whatever the latest version of Visual Studio is, and that should include edit binary, the edit binary tool or whatever. So if we take this and let's see, what's the command? All right, this should be the command right here. Your path to edit bin.exe dynamic base : no, and then your target file there. So let's go ahead and run that. I'm assuming no error means we did good. And let's go ahead and rerun Sims real quick. Okay, so put simply, I'm seeing an issue here where what we have in our debugger, so the game actually running in memory, the instructions at this address are different than the same address in Ghidra, which is static and just reading the file on disk. So that tells me that maybe there's something going on when the game starts where the file is changing. And so the file on disk is not quite a one-to-one match to what's being run in memory. And that makes sense now that I'm thinking about it, because there's probably like a game launcher that happens. In fact, hold on, we might be able to test this. Let me stop this version of it. Let's go ahead and open the attached view and let's run the game and see what happens. So it's still showing the same path. Gonzo. Hold on. What was that? Did you all see that? It said Gonzo as a title right there. You can still see it. 67740 is a process ID. Now it says a Sims Legacy. Okay, yeah, I think there's probably like a launcher or something that is like unpacking parts of the game or doing something to the executable after it's run, and that's changing what we see in memory from what we see on disk. So how do we get around that? Well, let's fall back on our malware analysis skills. What I would do if this was a malware sample and I saw that changing is download good old PECIV. If you watched my sandbox video, you'll know PECIV, one of my favorite tools. Basically, it just dumps a portable executable from memory. So let's go ahead and download the Civ64. And I probably want to use a command prompt to make it simple here. And what's our PID now? We are on 67740. And what I'm going to do is I'm going to dump that from memory. That should be in my downloads now. Let's see. Cool. So let's see if we load this into Ghidra instead, if that's going to be more accurate and show us the same address as we see in memory. Let's go ahead and do that. All right, so I'm at an address. By the way, I found this by searching for string reference across all the modules in debugger for Rosebud, and I actually see that C64C7C should hold that string value. So let's go into the new version that we dumped from memory, and let's go check out, oops, let me pull this over actually. Let's go check out that mod or that address and see if that matches what we're seeing here. I can't quite see it. There we go. C64 C7C. Oh, it helps to type it properly. Boom. Okay. Nice. So I see it. You won't see it cleaned up yet because it's still analyzing the new file. But in a second, when this analysis finishes and it kind of cleans up the disassembly view, we see Rosebud, the string is right there. So that's good. That means what we're looking at in Ghidra now matches what we have in memory, and everything is right in the world again. We haven't even gotten started yet. I'm just going to wait for this to finish, get some more energy drink for the road ahead, and wait for our auto analysis to finish. While we're waiting, what was your go-to thing to do in The Sims, like the original Sims, or even the more recent versions? Do you all like to do like the, you know, the, what do they call it in the new one, aspirations or whatever? Do you like to do those, or do you just kind of go and sandbox, or do you just mod around with stuff? Do you just do it for the building? What's your go-to thing for The Sims? For me, I like doing the aspiration stuff. I like having kind of a goal to go after, especially in Sims 4. There's so many different things going on. My wife keeps purchasing the extension packs or the expansion packs, so there's always more to go off of, but it's a little overwhelming. So sometimes I'm going in to do the aspirations and the missions and stuff, and other times I just want to cause chaos. It's kind of like playing Grand Theft Auto, another game where the cruelty of man is on full display. Analysis still chugging along. One other thing I'll say while we're waiting is, I can't remember if I talked about it directly in the question box video or not, but I always find it funny where you're, or at least for me, where my reverse engineering and like malware analysis skills come in handy, like using PECIV for something like this. It's really funny. I feel like reverse engineering has a lot of like obviously tangible benefits, direct benefits in a reverse engineering job or whatever. Or anti-cheat or whatever like that. But it's funny that as I've gotten more into the engineering side, like software development and engineering side of things, I feel like a lot of my reverse engineering skills have helped me become a better debugger too. So all that to say, I guess that don't underestimate the soft powers that your practice reverse engineering and malware analysis and whatever, even game hacking or modding has given you, because it's really cool to think about those little latent skills that we build. Anyway, I'm just waxing after midnight while I wait for Ghidra to load The Sims 1 so I can attempt to mod it. So what do I know? All right, took a bathroom break, came back, and we are looking better now. It's still running the analysis in the background, but we can see the string's been cleaned up, and we now have an actual functional cross-reference to that string, which was the same address that I found it in the debugger. So that's great. We will come back to this because I kind of want to start here. This is at address 45BC5E, really trying to get my dividends back from setting up that zoom feature. And we can see the string being put into this EBP, the base pointer plus local 40. So what I'm seeing here, just for those of you who may not be as familiar looking at this pattern. In fact, let me keep it zoomed in for a second. So anytime you see this kind of like sequential memory like this, so we've got a local variable, we've got a index into it like 0, 4, 8, 12. Those are, offsets into a piece of memory. So this is at the start of the memory block, 4 bytes in, 8 bytes in, 12 bytes in, et cetera, et cetera. That tells me this is probably, okay, our analysis finally finished. I do not want to go to the entry, but I'm going to go ahead and save our database so we don't have to do that analysis again. So this looks like a struct to me. And there are ways you can go into Ghidra and define a struct. I don't know if it will let me do it easily. Oh, wait a minute. I forgot the whole point. We have our AI. I wonder if it can do this for us. So let's ask, I'm trying to figure out where to put this. Okay, let's ask, can you define the struct at 0045BC5E? I don't know if I need to put 0x to make it specific, but I'll go ahead and do it. And let's see what it does. I guess it's not really defined there, but how can I word this? Can you define the struct that is at local 40 in function, where are we? 0x0045A0E0. Let's see what happens. Okay, specific fields were not provided, so it's a generic struct with no defined fields. If you have the struct details, you might want to find it in Ghidra. Okay, I mean, it didn't really change much for our view. May have made it worse, actually, but now that I'm looking at it, it's not as readable as kind of seeing where it goes. I guess that's fine. It's whatever. Can I undo it? I can. Okay, that's fine. Hey, it gave it a shot. It was cool to see that I can actually go in and do that. But the thing is, like, I don't actually know what these fields are, so I can't define it. The LLM doesn't know what the fields are, so I can't define it. But you can redefine this into, like, this is what I was trying to find in the convert. What is it? There's a way to convert this to a struct here. Okay, yeah, it's in this decompilation. You can do an auto struct, but it didn't actually work in this case, so we'll just leave it alone. But just know that that pattern that we're seeing there heavily indicates to me that we may be looking at a struct, because you can see it actually, oh, this is interesting. So along with Rosebud, there's a lot of other strings being put into a similar structure here. So you can see this kind of same pattern of the first element is some kind of integer. So like over here in the decompilation, maybe you can see we've got 5 set to this one for write desc list. In fact, let's go back before we get too far ahead of ourselves. Let's go back to Rosebud and see what that struct looks like in particular, because that's the one we're going to be working with most. So it's got kind of an identifier of 4C and hex, a string Rosebud, what looks like some kind of data address, but it looks like that's actually the same for all of these, which is interesting. And then this looks like something else maybe. Yeah, because that's no longer part of the same struct. Very interesting though. So what I find interesting is there's a lot of these being set up in this function. In fact, let's do this. Let's ask our trusty LLM, what is the function at 0045A0E0? I'm going to try it without 0x to save myself some typing doing. And let's see what it's able to define here. You can see it calling decompile function by address. Oh, no. The input or output tokens must be reduced in order to run successfully. Interesting. Okay, so I guess the disassembly was way too large or something, because it is a very quite big function. So let's try to narrow this down a bit by just asking maybe what can you, let's see, what can you tell me about the code between addresses 045 BC55 and 0045 BC76. This might, yeah, shoot. It's going to try to decompile it every time, and every time I think it's going to fail because it kind of has to decompile it. Okay. I wonder if we can say without decompiling the entire function, the assembly, oops. I wonder if that will help it or not. It's still calling disassemble function. Yeah, okay. There's probably a creative way to get around that limitation, but I'm not sure what it would be. So if anyone has messed around with GhidraMCP and has an idea, let me know. But for now, what I am seeing as a human is it looks like we're setting up a bunch of structs. One of them has the word rosebud in it, which makes me wonder if all of these, and looking at some of these other ones, I'm trying to think, let me pull up, actually, I think I have the Sims cheat list from the original game. Let's see if we also see like move objects here. Let's see. I think I can I do this? It is, okay. This is awesome, actually. So I'm pretty sure what this function is doing, just looking at these like repeated structs being created over and over with these strings, I'm pretty sure this is setting up all the cheat codes, which is really awesome because that may help us later on when it comes to the ladder thing. So let's go ahead and rename this. You all always get on me for not renaming things properly when I do this. So let's go ahead and rename it to sets up cheats. And is that how I do it? I don't remember this. Okay, yeah, I don't remember that view for doing it. Maybe I did it the hard way. Oh well, either way, I got the same effect. So now we have that labeled as sets up cheats. Going back to our original goal of figuring out how to get more monies, let's go ahead and find out. Let's see. I'm trying to think of what direction I want to take this. I guess let's go ahead and start by finding out when this is run, because maybe that will tell us, or maybe the better way to do it, actually, let's do this. Let's set a breakpoint when that string is accessed, and then run the cheat, and then that should show us what happens after the cheat code is received by the game. Let's do that. So back to our debugger. So C64, C7C, I'm now in my, by the way, I clicked into the dump. I'm pointing it with my finger. What am I doing? I clicked into this guy down here so I can open it in the dump view. And I typed a ZZ for some reason. There we go. And we can see right there, that's where Rosebud, the string, is stored. So what I'm going to do is set a breakpoint, a hardware access breakpoint on that byte, basically just saying anytime that string is accessed or the first byte of that string is accessed, pause, breakpoint, and then we'll see what's going on at that point in the game. So let's go ahead and go back to our live view here. And oh my gosh, what is it? Control Shift C. Yeah. Rosebud. All right, and we hit our breakpoint right away, so that's good. So we put the cheat code in, and then we get, so the breakpoint happens on the instruction after whatever accessed that string. So this instruction is actually the one where the string is accessed, and we can see that the address for Rosebud is an EDX, which was moved into AL here, or the data that was in there was moved into AL there. Okay, so let's go ahead and take this address right here and open that in Ghidra to see what's going on here. Give it a moment to decompile this function. So we're at 964490. So this looks like it's just processing. Yeah, so this looks like it's looking for a null character right here to end this loop. So this is probably just loading in the string. Where is this actually called from? Many, many places. So actually, let's go back and see. I don't think this function is going to tell us much except that it's processing a string. So let's see where we actually were called from. We were called from 44F170. So that's from the stack return value there. So 44F should be in here, I guess. Hold on, let's see. 44, did I read that right? 0044F170. Okay, yep. So right before 170 is our call to that function. And this is in another large function here. So there's our call to whatever that string kind of parsing function was. It's another pretty big function here. Let's see what else is there. Just looking at some of the strings here, it looks like maybe validation of the cheat code because it's like expected one parameter. What else? Format is blank. Couldn't parse parameter, expected no parameter. So maybe this is like a validator for the cheat codes. Parameter should be digits only. Selected person's interest. Okay, so let me zoom out here so you can see some of the other stuff. Simulation logging has already begun. Simulation logging has not yet begun. Size. Okay, there's a lot of different cases here that we're going through. Oh, hold on. We were here. Hold on. How do we get back here? Go back here, please. In the disassembly video, right here. Okay, wait. Where do we start looking at cases? Down here. There's a reason. I'll explain myself in a second. So I see there's a switch statement here. If you're not familiar, switch statements, you pass in an argument, and then based on what that argument is, you can match it to a case statement. So if this argument is 0, we'll run the code under case 0. If it's 1, we'll run the code here. So I want to go ahead and skip down here, because just looking at like all these different strings that are occurring depending on the case, I think this might have different validators for different cheat codes, and we might have like a particular case that's mapped to the Rosebud cheat code. In fact, before we do that, let's go ahead and ask our handy dandy if it can. This is a problem with this, is I don't know if this is going to be able to decompile a lot of these big functions to be able to tell us much, but let's see. So what can you tell me about 0x004f0b0's function? Kind of wrote that weird, but it's okay. Oh, here we go. Okay, so just kind of did the quick summary. Didn't do a full decompilation. Can you decompile it and tell me what it seems to be doing? I also don't know if this limitation of tokens is something that I'm doing wrong on my end, because I've only tested GhidraMCP on some smaller files, so I don't know if maybe I need to up my limit or something on tokens. We'll see what happens. Yep, it seems to be choking again on these bigger functions, which that's okay. It's not perfect. Again, it might be something I'm doing wrong. So maybe you gurus, MCP gurus or Ghidra gurus can correct me here. It looks like it keeps timing out or it can't load that many tokens or something. Anyway, doesn't matter. Let's set a breakpoint on this command, that switch, that jump table here. And I want to see if we can tell what code is going to run after we put in Rosebud. I think what's happening is up here where we were looking before, we have some validation that's going on. That's where we're broken right now in the debugger. And then once we get down to that jump table, I think that's where we're going to see, we're going to split out to go to whatever command Rosebud maps to, and probably see some code there. So let's go ahead and go to that address. Out of range. Did I copy the wrong address? Oh, I keep hitting the wrong key. That's why. No, it is out of range. What? Is that not what I typed before? You guys are going to have to call me out, because I could have sworn that's the expression I entered and it said it was out of range. Maybe I fat-fingered something. It doesn't matter because we found the jump statement. So this is where, depending on the value in EAX, which should be, well, actually, I don't know what it should be yet because, yeah, depending on what that value is, we're going to jump to a certain part of the code. If I put this in GraphView, it might be easier to look at. It is not. Never mind. This is what I'm looking at now. You can see all these different jumps to all this different code depending on that input. But anyway, you get the idea. The jump table is kind of the representation of that switch statement in assembly. And depending on the inputs, we're going to go one place or another. So let me set a breakpoint on that jump, run up to then. Oops, what happened? Oh, we just went to the return, I think. There we go. Okay. So whatever value in EAX. Yes. Okay. So I want to show you something. The value in EAX is 4C in hex. That's going to decide what branch we take in this switch statement. And the reason I'm excited about that is because if you remember, when we looked at where Rosebud was defined back here, that 4C value was the one that was set up in that struct. So I'm thinking what's happening, again, all this is some assumption, but some kind of divining from what I'm seeing in the code. I'm thinking that that 4C is kind of an identifier for that sheet, and that tells that jump table right here, or the switch statement, whatever you want to call it, to go to case 4C, and whatever code is under that case is going to run whatever code like actually gives you the money. So let's go down to case 4C, and let's see what it holds for us right here. So if blah, blah, blah is not equal to 0, if that's not null, then run this function. Oh, yes. Okay. So sorry, I've got so much stuff going on in my brain I need to share with you all. So right here, this function call, without even knowing what these functions are doing, this stands out to me because I happen to know from experience that the Rosebud cheat code gives you exactly 1,000 simoleons. And so I'm thinking that this right here, wherever we got this IVAR8 from, is our amount of simoleons, which is exactly what I wanted to find, because if we can find that in memory, we can adjust it to be whatever we want, really. So let's go ahead and label this as simoleons. I think that's how you spell it. Simoleons. I think I did that right. Yeah. So let's go check this out. It looks like, hold on, what are we passing in here? We're not passing in anything. So interesting. At least not that Ghidra is showing us. This decompilation, as I've talked about many times, is not perfect. And so we may actually be passing something in from the stack here. That's coming in as param1 because it's supposed to take an integer in. And somewhere hex 50 or 80 bytes into that memory, we're going to check to see if that's not equal to 1, and then we're going to go to 144 bytes into that memory and return that as the simoleon value. So all that to say that all we really need is to know what that parameter is, And that parameter should tell us, that parameter plus 90 hex should tell us where the simoleon is. So let's go ahead and label this as well as simoleon struct start, I guess would be a good name. Sorry, I just realized I'm still zoomed in. There we go. And to cheat, let's go ahead and go to the debugger and figure out exactly what it's going to pass in there. So let's go ahead and skip ahead. We are looking for, let's see, the call happening on line, what is it? F556E50 is the function address. 556E50 right here. I'm going to go ahead and set a breakpoint. Let's go ahead and run to that. And on the stack, we have this address. Let's go ahead and, can I follow that in the dump? Okay, that might be a pointer. Let's go ahead and see that. Yeah, that's right. That's the start of the struct. So let's go ahead and step into this function. And let's see what happens here. So check that one, whatever, blah, 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 move, and then ECX plus 90 is where our simoleons are stored. So let's go follow and dump, ECX 90, 299 hex. I need my calculator, sadly. There we go. 665 decimal, which is, if we open up our game again, oh, the game is actually frozen. It won't show me the window because we're paused in the debugger, so I have to minimize everything to actually see it. Yes, $665. So that is our byte, I'm guessing, or maybe 2 bytes there. That is storing our simoleon. So this is perfect because we can now, if we were going to write a cheat code for this, for example, we could write a script that would look up that address, maybe dynamically, maybe not. In fact, let's see. This is 4AB4D70. Let's see if that's actually in Ghidra as something defined. Let me zoom out here. So 4AB4D70. 4AB4D70. Okay, so it's not something that's static here. So that address might be, excuse me, calculated dynamically in some way, but we could write a cheat code. Oh my gosh, hold on. We could ostensibly write something that would hook this function and find out what that address would be. And then we could, patch over it using our program. For now, all I'm going to do is edit it in the editor to kind of show you how this would work. So I'm guessing this is going to be unsigned. Let's see what happens, actually. Let's see what happens if we set this to FF, the last byte. Let's see what that ends up doing. Let's go ahead and run the game. And we now have, okay, yeah, so we have 0. So it is actually signed. What I mean by that is this integer here can be a negative number or a positive number. And we could probably do something like, we could probably overflow it actually. In fact, let me see if I can just quickly do that. If I edit these bytes here, fill with all Fs here. That's going to probably break things, but let's see. And if I do Rosebud again, we're hitting our breakpoint, so I'm just going to skip through all the breakpoints. 999. So interesting. It went back actually to that value. What is that telling me? So something's happening that's actually editing this back to, or no, that may make sense. If we, yeah, okay, I got it now. All of the hex math people are laughing at me. So when I made that all Fs right here, that was in in signed integer world, that is -1. So this value is -1 in hex. So when I added 1,000 to that -1, I got 999. So that's okay. This is just confirming that this could be a negative or a positive. So if we set this 1 below, All right, there we go. Sorry, I was getting a little bit down a rabbit hole there because I was noticing that this number here. Oh no, what have I done? I tried to do the wrong code shortcut key because I thought I was on a Mac. There we go. This number here, if you change it right here, it won't immediately update the screen. So what I did instead is I put in the biggest number this byte, these bytes, I should say, this D word can carry, which is what, 01100070. That's what I had at my calculator up here that I was calculating that. So that's the biggest number minus 1,000. So let's set that right there. And let's zoom back out and go ahead and type Rosebud again. That should add 1,000 and get us right beneath the point where we would have flipped to a negative number and overflowed it right here. And we should have, yep, basically close to 1 billion simoleons, which is as close, at least I'm happy enough with that as being infinite money. And I could get into a rabbit hole on exploring this more, but I'm happy that we figured that out. And let's just test by buying something that it won't mess up and reset or something. I guess I can take out and disable my breakpoints now and get rid of these and just play the game. It's actually not even taking away from our bank. So I'm guessing there's a part of the code that might be like have some kind of validation that's failing right now, because it doesn't expect us to use a number this high. So I'm guessing that's what's going on, and like we have so much money that it literally cannot handle it. So to me, that's as good as an infinite money glitch as you can get, and I'm happy with that one being crossed off because we don't have time to dig much more into that. Let's move on to the next objective, which was the moodlets. Let's see if we can get it so that these moodlets here down here, let's see if we can make it so that they don't always decrease and that we don't have to worry about them. We can just make it so that we can play the game without worrying about the moodlet part. So to do that, where do we begin? I think the first step is to probably look for maybe some of these strings here. Let's go ahead and minimize some things. Like energy, bladder's probably unique enough that if I search bladder, we can probably find some hints similar to what we did with Rosebud. We can find some hints to where that value might be getting adjusted in the code, and then go from there in, oh yeah, here we go, jackpot. Like you can see all of them listed here, probably getting rendered. And then you have bladder decrement while awake and bladder decrement asleep. So let me think here. Let's start with one of the decrement ones. Doesn't matter which one, I guess awake. Because this tells me that whatever's referencing this string, here's what I'm thinking about. A string called bladder decrement awake and bladder decrement asleep. Those are probably referencing how much of a value to take away, a ratio to take away from the bladder value. And so if we can find what code is interacting with this, maybe we can find out how the decrement is happening. And if we can find out how the decrement is happening, similar to the Rosebud thing, we can find where that value is stored. And maybe if we find where that value is stored, we can either make it infinite like we did with Rosebud, or we can just stop that code from running by like overriding it with something else to make sure that none of the moodlets can decrement. So let's start there, I guess, and see what's using this bladder decrement awake value here. Oh my goodness. Okay, so we actually see a bunch of different moodlet decrementations here. Energy drift, wake hours, wake hour energy span. So, whoa. Okay, so this looks like it is sending these into a function, maybe setting some default values, although these, oh, okay, yeah, and they're floats. Okay, so this is an important distinction. So this hex value in decimal integers is a huge value. But when you convert it to a floating point value, so like a number with a decimal point, basically, we get a much smaller number. So that makes sense. So this looks like maybe it's setting up some initial values for these things. So like while you're asleep, you might subtract 0.2 from bladder, or a ratio, maybe it's a ratio percentage. And while you're awake, you subtract 0.3. Let's see what else makes sense. So while you're active, you might decrement 0.4. While you're lazy, you might decrement 0.6. Would that make sense? If you're lazier, you're decrementing a bigger ratio? I don't know. Yeah, we'll dig into this more. Let's go ahead and ask our Ghidra friend. I really want GhidraMCP to be useful for part of this. I hate to say it, like, it is a useful tool. I've used it on malware analysis and it's been great. Like it was doing great with the decompilation. I think this game just has so many huge functions that it just has been choking it out a bit. So let's say, can you decompile and tell me more about function 0x00683060? Please, pretty please. Let's get a refill of caffeine here soon. If FARx is greater than 100 or less, yeah, greater than 100, it equals 100. Okay. If it's less than negative 100, it equals negative 100. Okay. Oh, it's big brain time. So I think, not really even, this is very basic float point arithmetic, but I think what's happening is we're doing a bounds check here. So what I mean by that is this is going to be some moodlet value. And we're checking to see if this is greater than 100. And if it is, set it to 100 as default. If it's less than negative 100, set it to negative 100. So we're putting a bounds on it. So what I'm guessing is that these moodlet values aren't a 0 to 100 scale. It's a negative 100 to a 100 scale. So like maybe right in the middle of that green red bar is 0. Far red is negative 100. Far green is 100. That's what I'm guessing right now. And then blah, blah, blah. This is, I don't know what this is. Oh, and float, that's 100. Okay, interesting. So let's convert that. Ah, no, what just happened? Convert to, oh, did I just mess something up? Is my Ghidra acting up? Oh God. Yeah, sorry, I was doing a refresher on how to read these floating point values in hex, and I've already given up after seeing the word mantissa here. Mantissa, I hardly know. I'm trying to think. So we know where they are. We can kind of maybe set a breakpoint on these values and see where they're modified, and maybe start there. Isn't there a cheat code or something too that you could like affect the moodlet somehow? Let me see. This is a very interesting turn of events. So I had pulled up this site here with legacy collection cheat codes. There is, if you remember, I've used this site before, the cutting room floor, really cool. It kind of talks about like hidden stuff in games. I think we used it in the solitaire video, I want to say. They have an article on The Sims, and they said there's 28 cheats-based commands that can be natively accessed, depending on the expansion packs, maybe more, maybe less. And the ones highlighted, the Sims have them working yet capped, and they're highlighted, sorry, let me try this again. Jesus Christ. The ones that are highlighted in red are capped, and so they're not available, I guess, but they're working. The ones in green should work in all versions. So there's one of these. I was looking at moods and moodlet, and then I found the word motives, which I think was the other name for this. There's actually a capped, whatever that means, capped. I'm assuming that means like deactivated or something. Cheat code called motives that turns off the motive engine for all people in the house, which is exactly what we want to do. That's exactly what we want to pause, is all the engine that subtracts those things or adds to those things. So I'm wondering if we will find a reference to that in the legacy version. if I type motives. Now I got to be careful because like motives could appear in other contexts as well. But let's see. Okay. This is good news. So the fact that we have a cross-reference here from the string motives means that this function we looked at earlier, oh, this is awesome. The function we looked at earlier that set up the cheat code still has an entry for motives, and it's assigned to branch D of that other function, which I'm trying to remember what we called that. Did I call it anything? I don't think I did. Okay, here it is. We should call this something. So jump, or did I do this again? I don't want to set comment. I want to rename it. This is the window I was looking at earlier. I think I just pressed the wrong key earlier. So let's do this jump table for cheats. Perfect. And so, crap, I already forgot what entry it was. C, I think? Or D. I think it was D. Let's go back real quick. Yeah, D for motives. First of all, let me see if this just works out of the box. That would be the easiest. The path of least resistance is we can just use that code. Let me get rid of this hardware breakpoint completely, actually, and disable this. And disable this real quick so we can just play. So if I do the cheat code motives, no such cheat. Okay, and actually, we didn't even see this breakpoint on the jump table break, which means that this cheat, when I enter that, it's not even getting there. So maybe that's what they mean by capped, or is it just not available? It's in the code, obviously, but it may not be available in the legacy edition or something else going on. Here's what we can do. Let's force it to call motives by just overriding what offset we go to in the jump table. So let's do that first. Let's try that. So let's put in a known working code. I'm sorry, I'm zoomed in still. Rosebud again, maybe. But right here, when we're going to go to 4C, which remember that was the offset for the Rosebud cheat. Let's change this to D, which is the offset for motives. And let's see what happens when we jump there. So there is like a jump table entry for D. Move EAX, whatever value's in there. Okay. Move EAX, whatever value's in that pointer. We're setting a bunch of values in the registers, comparing it to some, what is that number? Jump is not taken. Hold on, I need to kind of visualize this in the debugger here. So let's go back to jump table. Let's go down to entry D here. We see that if we get down to what should be the motives command to turn off the engine, it sets a value at this, whatever this address is, to this thing XORed with 1. So I set a breakpoint on one of these addresses right here. That's this guy right down here. I set a hardware access on that, and then I see that we are getting a read of it right here in whatever this function is. So let's take a look at this. So if that value is 0 and something, I'm thinking that this is something to do with the motive or moodlet engine. I'm just trying to decode what's going on here. So I'm wondering if we can, if this whole like if statement here is made to determine if the moodlet engine runs. So let's try setting this to null and see if we bypass this entire if statement, if that will actually stop the moodlets from actually like subtracting this guy right here, which equates to this in the disassembly. So let's go back here to, are we in the right place? I think so. This address. Yeah, right there. So let's go back. I'm gonna have to rerun this and play the game. Okay, right there. So this right now is not, the jump is not gonna be taken because this is not 0 or not null. So let's make this act by changing the 0 flag here. We're gonna make it so that the jump is taken instead. And we'll see what happens now. We're right back here. So nothing really changed, I don't think. All right, let's do this actually. Let's edit this command to just do, or no, that's not what I want. Assemble to just jump every time. That's the equivalent of what we're doing. And I want to see if that actually impacts. If I unpause my game now, oops. Play that. Oh, disable that breakpoint. Run. It just crashed. No, wait, it's there. Okay. Did that work? Everybody's frozen. The music is still going, but everybody's frozen. So, okay, I think that check right there might just be a check to see if we're paused or something like that, because that's how it's acting. It's acting as if I paused the game. So let's undo that patch that we did and change that back. Can I do that? Patches, where are we at? FC, yeah, select all and restore. Okay. That should be all. So I think that's what's, yeah, okay, we're good now. I think that first check is just to see if we're paused. So maybe that's actually good because that's a piece of it. So when we're paused, we're not impacting the moodlet. So I'm pretty sure we've homed in on the spot of the code where the moodlets are being adjusted. We just need to figure out exactly how that motives cheat was supposed to work and see if we can cause it to like stop the moodlets from moving while we're still playing, if that makes sense. It has to do with this thing right here because that's where we ultimately saw the motives cheat adjusting, but I'm not quite sure exactly what it was trying to do here. Okay, I am noticing something that's boggling my mind. So, first of all, Bella and Mortimer just died for no reason. I'm not quite sure. Maybe I messed something up there. I see that some of the moodlets are still going down, like social, fun, room are all going down. The energy, hunger, comfort, hygiene, bladder are all staying constant, I think. If I see, like, what's something that we can do to get hygiene down? Maybe if you go swimming. Why is everyone peeing and dying? Yeah, people keep dying, so that's not good. But on the plus side, our moodlets, like the main ones, are not going down at all. They're staying constant. So I'm wondering if that cheat only impacts some of these motives and not others. Let's take a closer look at that setting again. Okay, yeah, when I set it back to 0, they immediately go down. And I think, did I patch something and not realize it? Because everything's going down so fast. I think I need to quit out of this game and reload. Let's see what happens. Or something's happening where when I modified that motives cheat, because I hijacked Rosebud again, maybe a Rosebud is passing in. Oh. No, it wouldn't pass in 1,000. Let's try this. Let's well, it didn't save anything I was doing. That's fine. Let's try a different cheat and see if something different happens. Because I think maybe the values that are getting set by the Rosebud cheat are like impacting us negatively. So what's a nice safe cheat we can do that won't have like a preset value, I guess. Gosh, I don't know. Let's try the interest cheat, which just is a dialogue showing the selected character's interest. Let's see how that works. Oh, you know, I need to attach to my debugger. That would help. Make sure our breakpoints are set. Okay. So let's go down to, as usual, option D. And we get down here. We set this to 1, which I think is what we want if we want to stop the moodlets from detracting or subtracting. Let's keep going and play. So no one is dying immediately, so that's good. And our moodlets are staying constant except for room, which I would expect to still go up and down because that's just based on your surroundings, right? Fun, same thing. It's not impacting, you know, their life, I guess, or their ability to live or die. So I guess that makes sense why it would go up. It's not going down though, actually, now that I'm looking at it. So I think we've done it. Just to check. Let's see what happens when we do this again, but we put it back to 0. So we're going to skip again down to case D, which is the moodlet cheat. Sorry, I haven't been really paying attention to where my head is at, so you may not be even seeing what I'm looking at. So right now, this value is set to 1. That's what we changed it to when we ran the motives cheat, or we hijacked it and ran the motives cheat. So now let's change SI to 0, which is basically setting it back to what it was before we ran the cheat, and see if they start subtracting again. I don't... Oh, there they go. Yeah, okay. Okay, I feel better now. No one's... I think what was happening before... I'm going to turn this off because there's so much noise going on. I think what was happening before is because we're kind of using this weird hacky way to access a cheat that's actually not available for this version of the game, that Rosebud cheat probably like messed with the other input to the motives cheat and like set it to decrease the values, maybe by 1,000 even. I don't know if that... I thought the 1,000 was set somewhere else, but maybe like the simoleon number 1,000 got mixed in, or some value got mixed in, and I think that caused us to like all of a sudden start draining moods like nothing else, and people started dying and peeing themselves, which was quite funny but not very healthy. We were trying to save the Sims, not torture them further. It might have been the things I knocked out actually too, now that I think about it, because I think I knocked out the let's see if I enable that. I think I knocked out this jump here, so I think maybe I messed a little bit too much with it when I knocked that out to get past that breakpoint, because I thought I needed to, but I don't think I needed to. I think if I just used the motives cheat as intended and just set that value to 1, it would have blocked the mood engine from working, and if I set it back to 0, I think it would have worked. But I think something along the lines, something I modded, hilariously caused some other effects, including draining their moods rapidly. But now we have this running. I think we figured out the moodlet thing. So one more time, just to make it official, let me set it back to moodlet engine off by setting this ESI value to 1. Actually, yeah, that's what we want. And yeah, I think the arrows we just saw there were artifacts from before, but now I don't see anything going down. So, cool. We figured out the moodlet engine thing, and it really was an existing cheat code that I had no idea about. We just had to find a really weird way to bypass and enable it. So, all right, I'm going to call that one done because I've already spent like almost an hour just on that one goal. I kind of got into some rabbit holes there and confused myself, but it's all part of the learning. The good thing is that you guys will just see the edited version where I did everything almost perfectly by the end of it. So that's good at least. All right, next thing. Whew, all right, I had to get up and take a walk after that mind numbingness. So on to the next thing. I wanted to do something with the animations, but I'm thinking about this, and we may be able to actually, using the knowledge of what we have about how the cheats work now, we might be able to do the ladder thing first, and I think it'll make more sense in this sequence to do that first, because then I can introduce you to some of the tools we'll use for the animation stuff as well. So let me get out of the music. With that said, there are a couple of tools that I was exploring when I had the original idea to do the Sims video back when it was going to be more of a scripted thing, working on the ladder problem, but also exploring some of these old, just cool editing tools that are out there for the original Sim. So one of them is FARedit. We'll go ahead and download that one. This is on the archive.org website, actually. There's also this one, which I think, oh, that's right. Actually, there was something wrong with FARedit. I think I have it in my notes from that original video. Yeah, I think I had it flipped, or maybe I didn't. Maybe I can't remember which way I said it. So FARx is the one we want. There was a limitation with FARedit, this guy, where I couldn't import objects back in. And you may be wondering, what the heck is FAR? What are we talking about right now? Let's go ahead and download this and I'll show you exactly what it is. And as well as that, I'm going to get IFF Pencil here, IFF Pencil 2 here as well. So these are the only two tools we need to do some of the animation stuff. Or I take that back, SimPose as well we'll need. So we'll get those three tools. Hey, it's me, Jeff from the future. It's much brighter here, but I am equally tired as last night. I usually don't do reshoots, but approaching 4 o'clock in the morning last night, first of all, my voice was just getting shot, as I'm sure you've heard. And I feel like these last two segments of the video, I didn't do a great job of explaining the why or the how behind some of the things I was doing. Maybe just kind of rushing it towards the end. So I wanted to reshoot at least this last portion and do a little bit better job of explaining what's going on here. I don't think it'll impact anything that we've done so far, because a lot of this material was not just me figuring out stuff last night, but also a combination of that and knowledge I had gained from my previous experimentation back last year when I was trying to do a different concept for this video. So with that in mind, I want to start over. I know we talked a little bit about FARx and IFF. I want to have the AI actually present a good background of what those files actually are. And then, of course, a ton of the links I have in the description of this video will point to old documentation and tutorials about those file formats. So you can actually play with them and do some really cool stuff. I've only scratched the surface of the things you can do with them. So FAR files, or FAR files, as I call them, file archives. They're basically an archive, a bundle of files that is used by the Sims that carry assets within them. And I'll show you what that looks like in FARx in just a second. IFF, interchange file format. These are the actual asset data files. And these are the things that we're going to use IFF Pencil 2 to modify. And you can do, again, a lot of cool stuff that I haven't even scratched the surface of, like change the appearance, change the behavior. We will work on that latter part today for our objective of making sure the Sims players can never kill a Sim by removing a pool ladder again. But there are a lot of things we aren't going to touch on that you can modify in those IFF files that I think is really cool. But we can save that for a part 2 of the Sims. For now, there's a little bit of an explanation of what these two file formats are doing. Let me just get set up here and we'll pick up where we left off. All right, so what I've done here is I've opened within my Sims Legacy game data folder. There's a bunch of folders here that are categories of game assets. And within there's an object category, and I've opened that up and I've scrolled down to the pool ladder IFF object. Now I have this open in FARx, so I need to actually extract the asset out into downloads. Let's say, yes, I had already extracted it yesterday. We're going to extract it again. Then I can take my IFF Pencil 2 program, which, by the way, you want to make sure this executable is in the top level of your Sims Legacy folder, because if you don't, you open it like this, you're going to see this message that says, I can't load behavior.iff, a different asset file. What that behavior IFF does is, excuse me, when I go into the behavior objects here, and I open up what is really, they call it semantics, but it's kind of like the programming language used within the Sims behavior editor. you're only going to see a bunch of numbers here. And it's not very helpful if you're trying to modify that behavior. But if you are running IFF pencil from the top level and it can find that behavior.iff file, when you open up a behavior object like this, you're going to see now kind of like a simple scripting language being used that's a little bit more human readable. So for example, this is pre-enter the pool ladder. So change suit accessory. So changing the Sim's clothing to the swimsuit, maybe checking if the person is swimming. If not, animate them to swim, something like that. I'm kind of guessing at what this is doing based on some context clues here, but what you'll see is an instruction, a line, and then a next column that will show you if the line is successful, what happens next. So for this one, if it's successful, it just returns true. If it's failed or if there's an error, it goes to line 1. So you can think of that as if the Sim is in the pool, don't change into the swimsuit because they're already swimming. They don't need to be animated. They don't need to change anything. But if they're not, go ahead and change them. Go to step 3 or step 2, I guess. Change it to swimming. Move to step 4. Animate them. If there's an error, try to go back to step 3. That's kind of how you can read through these IFF files. And sorry, I just realized maybe, I think we're good there. So how does this all play into our quest to save all the Sims? Well, let's go ahead and open our game back up. Now I will say you need to close out of this file, or actually you might need to close out the whole program, of FARx when you're running the game, because you're going to run into a permissions issue where because you have that objects.far file open in FARx, the game won't be able to access it. So let's reset here and start up our game. All right, so I built a little pool here for Bob to show you what our objective is and what we're up against really with these sick people. So Bob's in the pool, he's swimming, he's having a great time. He's living his best sim life. We delete the ladder. What happens to Bob now? Well, Bob is going to keep swimming. He's going to keep swimming and swimming until his energy or hunger or bladder is depleted and he's going to die. And that's what these sim players want. So how do we defeat that? How do we get rid of that option to delete the ladder? Well, for those of you who remember this from playing Sims, there are a couple objects that cannot be deleted, at least not without cheat codes, in The Sims 1. One of those is your trash can, which you can't even pick up, and one is your mailbox. So maybe we can use one of those two objects as a template, open those up in IFF pencil, and see what properties they have that make it so that you can't delete them. So let's go ahead and do that. I need to open FARx back up here. And let's go down, let's just grab the mailbox and extract that. Also, I'm realizing I still haven't gone through and really talked about the format of these IFF files. So let's do that real quick. Again, a lot of this I picked up when I was experimenting, and actually I used an LLM to help me explain a lot of it too, along with the tutorials that I'll link to. So let's just ask our AI buddy, what are these different resource types? So you've got SPR, hash, which is sprite, visual representation of an object, bitmaps, object data, object functions, which uses the semantics code that we talked about, string table, CTSS catalog strings for object description, sounds, behaviors, functions, and pie menu functions. So again, it's very powerful to be able to edit these in IFF pencil. You can probably do some really cool mods and stuff with them. And some of the tutorials I'll post have some like from scratch mods you can make. But for now, what we want to home in on, and I'll tell you some of the other things I tried here, is let's look at the object definition. You can see a lot of different metadata here, like price, you can change the sales price, IDs, and then a bunch of attributes that you can kind of see laid out here. Back when I was first experimenting with this object definition file, One thing I played around with to see if it made a difference was the type, because you can see there's different types of objects like internal, cursor, portal build mode, sim type, person. And I remember that that actually did not help as much as I thought it would in making something undeletable. No matter what I changed a type to, it didn't really help that much in my case. So what I ended up doing is instead looking at the behaviors. So if you look at the behaviors here, you kind of see these, we'll call them equivalent to like function names, like main, load tree, process, and then every object has kind of its own things, like this one's get mail, something like that. Kill bill from hand, as you do from your mailbox. Maul me friends with everybody, make all happy, etc., etc. Actually, that one probably would have come in handy earlier when we were doing the motive stuff. But for now, let's look at just the main method for the mailbox. Or actually not main, let's look at load tree, because that seems to run before kind of the rest of the behavior. So here's the key part we're looking at. These two lines here. Players can move it. More importantly, probably, players can delete it. So this appears to be setting a flag that will, well, it appears to be clearing a flag, I should say. And clearing that flag will make it so that players cannot delete an object. So if we can take the code that's here and add it to our pool ladder behavior, then we should be in business for ensuring that it cannot be deleted. So let's try that. I'm going to take a screenshot of these values because once, at least there might be a way that you can actually type in the text that I haven't not figured out yet. But for now, all I've been doing is editing the data over here to make this line. So let's go ahead and open back up our pool object, or pool ladder object. Go to behaviors, and we want to pick again a method that we know is going to run at the start of the object being created or used or instantiated. So load tree I found is probably a pretty reliable one. I'm pretty sure that's run every time the object is loaded. So right here, we only have one instruction. And if it's successful, we just return true. If not, we return an error. So we do need to change this. We need to add, right-click and add another line of instruction, and then change the true condition here to when, if it's successful, go to line 1 instead. And then we'll change this to return true so that we don't break the sequence of anything else going on here. Now, the rest of the data I'm going to pull from my screenshot over here of the my movement flags clear flag, players can delete it. So I'm going to just, I don't think the revision matters as much, but I'll go ahead and change it to match just in case. Function 2, oops, nope, I want to leave that one alone. Parameter 1 should be 43. That'll get us my attribute, or maybe, oh, I see, it's gonna load a field, particular field here. 43 for 2815 1795, and you can see as I edit those numbers, the context of this changes quite a bit, and this is all getting loaded from the behaviors.iff file, this text here. So that should make it so that we run our first line, we go to the next line, we clear the players can delete it flag, and then we continue on as if nothing has changed. So let's save that. Let's drag that revised pool ladder object back in to FARx, overwrite it, save the FAR file, close this so we don't get a permissions error, and let's start it back up again and see if we can not delete it this time. All right, we've loaded in. Bob's having a great time. Now, look at that message at the bottom. In and out ladder cannot be deleted. I'm pressing delete right now. It's not letting me. However, the scoundrels who know this trick well know that there's always a way to get around this, and the same thing with the mailbox. You can use the move objects on cheat to pick it up and delete it. So we haven't won the war. We've won the battle, but not the war. So what do we do now? Well, first, let's put back the ladder, and let's open our debugger again. And we can use the knowledge we've gained from earlier in this video to patch that move objects on cheat in a way that will prevent it from running. So let's see here. Let's go ahead and attach, I don't know what I just attached to there, and zoom into our house and then click move objects on. So if you remember, that takes us to our jump table here. Let's go ahead and open this up in Ghidra again. And let's check what this switch statement right here is doing. Is it this one? Oh, I'm sorry, I went to the jump statement. I need to go one more step here to where it jumps to the actual code, and that's at 44F6BB. Make sure, you probably can't see it very well, but I'll open it up in Ghidra right here. What in the world did I just copy? Copy, oh, I probably copied the binary. Whoops, copy address. Go to address, very good. So right here, case 10 is what we're looking at, or A in hex. And it looks like all this does is set a piece of data with this variable, and that's it. So this should be easy to kind of neuter here, if you'll forgive the use of that word. It's a little extreme. But all we should be able to do is go to that line where that variable is being set in memory and just nop it out. So fill with nops here, just so you can see this. Binary, fill with nops. And it's going to do that. And then let's go ahead and run this, and it shouldn't change anything in the game now. So we still shouldn't be able to delete the ladder. There we go. And we cannot delete it. So we have effectively beat the sadists who are trying to kill the Sims by patching over that instruction and ensuring that no matter what, they cannot take out an existing ladder. Well done. We won that battle and that war. At least I'm going to call it that. There's probably ways to get around this, I'm not going to lie, but I'm satisfied with the work we've done so far there. Let's move on to our last objective. All right, so our last objective was to do something fun with the animations, and I'm actually glad that I'm reshooting this portion because I went through a few different ideas last night that all didn't pan out very well. The one thing that did pan out that I thought would be a little silly and funny would be if we took the diving animation from the Sims like diving board and made it so that anytime a Sim tries to get into bed, they have to dive into bed. Some background before we do that. Within the same game data folder, there's an animation category of assets here that you can open in FARx, and this animation.far file that has every animation in the game, and there's a ton of them. You'll see these prefixes like A20, C20, some of these don't have the same ones, Xskill, C20, A to A. My understanding is that those are representative of things like the A20 is adult to object, C2A is child to adult, C20 is child to object. So there's different categories, and you'll see those prefixes come up. The reason I bring that up is there's a cool program called SimPose, same file or the same link I showed you earlier, right here. This lovely old school looking site, SimPose. And I also included one of these tabs is a tutorial for SimPose. I want to say it's this one, yeah, that somebody wrote where you can actually make your own animations, which is really cool. I am not that smart or technical with this program. I played around with it a little bit when I was doing the initial experimentation, but I didn't get very far. But you can like keyframe stuff, you can load existing animations. And so in this case, we're not going to really use SimPose for this kind of workaround we're going to do, but I did want to show you it because I think it's cool. So if we go open this up, again, you want to make sure it's in your game base folder, because if you do that, you can click load CFP animation and you'll see every animation that it loaded from the game. So if we go down here to Xskill, C20, pull, dive in. This is really what I'm looking for. Right? This is the child to object one, but I mean the dive for the child and the adult is not so different. And you can play that animation back and you can keyframe it, edit it, do whatever you want to it. But it's really cool. You can see that. So I want this to play anytime that our Sim goes into their bed. How do we even start on that? Well, if we go back to our IFF pencil, let's go ahead and open up Actually, we need to extract a couple things. So let's extract, going back to objects. Let's extract the bed object, the base bed object, and let's extract the diving board object, which I think is called pool diving board. Yeah. And let's put those into downloads and open them up in IFF Pencil. Let's start with the pool diving board first. So when you're opening up the IFF file, you might be tempted to go look at the behavior to see where these animations are called. And it's true that if you go to something like dive, you might see, maybe not dive, maybe, let's see, common load tree, dive test. Yeah, the portal function. You'll see a lot of animate sim calls here. ID 5 from object event 3. Those animations are actually loaded from a string table here. And you can see there's an A2O and a C2O in the string table. And if you look in the A2O, you can see all these different IDs and the animations that they refer to from that animations.far file. So instead of messing with the behaviors and the animate sim calls, all we really have to do is replace whatever animation calls we want in this string table with the name of the animation we want to load instead. So I'm going to copy this dive in animation name, and we're going to put that into the bed animation for getting into bed. All right, so I've opened up the string table for the beds.iff. Let's replace, there's a lot of different animations for getting in bed, because you got getting in bed on the left side of a double bed, getting in bed on the right side of a double bed. We're going to replace every instance of get in the adult and child table with this diving animation instead. So let's see, get in there, lots of get out as well. I think those are all the adult ones. Let's go to the kid one just in case. We don't have any kids in our household, so we really don't have to do this part, but why not? And there's not just get in for the double bed, but down here there's get in for bed single, right side, or get in, I think there's one more. Yeah, left side here. So with that, let's save our beds.iff. Let's load it back into our objects.far file. Refresh this. There we go. And save. And close. And run. And go. And bop it. So we're in the game again. We need Bob to lose some energy, though, because you can't actually go to bed until your energy hits a certain point. You'll see there's no actions available. So let's wait. Let's let him work it out a little bit. And let's sleep and see what happens. I want to see an Olympic swan dive here, Bob. Okay, pajama animation. There it is. So stupid, but so satisfying. Yeah, that was me when I stopped recording last night. That was a rough time. So let's pause there. Pause the music and everything. Well, I'm really happy I had the, I guess, wisdom and humility to come back and re-record this, because if you had seen the raw footage from last night, I was crashing out trying to explain what I was doing here, and losing my voice, which I'm still a little hoarse with all this, but I was so excited I just wanted to finish it. But I'm happy to do this again because I feel a lot better about the explanations of everything. I hope you were comfortable with the explanations of everything in the end there too. I know I cheated a little bit because I had done, even though this is disassembly in the dark, I had done some of that manipulation and playing around with those programs back in November, I think, of last year. So I remembered quite a bit from that first round of experimentation. But what I didn't expect was to combine that knowledge with what we learned about like how the cheats work, for example, last night, and use that in combination with like disabling move objects on to really make the delete ladder thing a non-issue, which is really cool. Yeah, I don't know what else is left to say other than thank you so much for being on this journey with me as usual. I feel really, really reinvigorated, if it's not clear. I've had some really hard times these last few months, like sitting down and getting in the right mood and vibe to film a video like this. And this has just brought all the fun back into this video making and this process for me. So thank you all for the opportunity to present this to you, for coming along the journey with me. If you made it this far, let me know what you thought of everything. I hope you learned something. I hope it was useful. And yeah, let me know what you want to see next. Do we come back to this and do some other stuff? Do you have ideas for other things we should modify in The Sims? Or what should be our next program of choice to reverse engineer and play around with? I don't know, but I'm sure it's going to be a great time. Thank you so much for joining me. I'm Jeff of All Trades. We may not have mastered this one, but we're a heck of a lot closer. Thanks so much for watching, and I'll see you next time. Gosh, this music is so beautiful. It's a shame that it's the last thing you'll hear here in your party room, Bella. Some people are so cruel.